Yeah, I finished my other exam set and I'll be starting yours today. You do have homework due this Friday, okay? Every week except exam weeks, you will have a homework assignment due. And that assignment is posted on Blackboard. Any questions about anything? Okay, let's share the screen and get started. Oops. Wait a minute. Okay, now share the screen. Okay, let's see. All right, we've been talking about the differentiation rules, and yesterday we derived the derivatives for the trig functions. So we're continuing to talk about this. Rules, and I also called them laws. That's D. A, we have a pretty long list now. We can handle a lot of situations. Now let's work some examples. Okay, I thought we would do this one first, so a little practice on the trig functions, and also kind of a similar one. No. Okay. Just for comparison, okay, these are two different functions. In the first example, y is cosine of the tangent of x. In the second example, y is cosine x times tangent x. Sometimes students ask me, how do you tell the difference? Yeah, this is a composition of two functions. This is a product of two functions. I can tell that this one is a composition because it's, well, the tangent is inside the cosine, okay? You're taking the cosine of the tangent of x. Here, in this one, I take the tangent of x, I take cosine x, and I multiply them together. So this is going to require the chain rule. And this one's going to require the product rule. One of the things you're going to be learning is how to pull the functions apart, how the functions are put together. Is it a product? Is it a sum? Is it a composition? That sort of thing. Okay, but this is a composition, and that means we're going to need to use the chain rule, which is right there. No, okay, there, okay, right there. Okay, which means you've got to identify your inside function and your outside function. The inside function which we call u usually, is the tangent function. So the outside function is cosine of u. All right, so the chain rule says, let's see. I'm thinking whether I should name this. I'll call this F. Okay. The chain rule says that the derivative of F composed with U is F prime composed with U times U prime. Well, F prime is the derivative. Let's see, let me put an argument in there. Okay. F prime of U is the derivative of the cosine of U is minus the sine of U. And U prime, and its argument is X, U prime is equal to the derivative of the tangent, which we found out yesterday was secant squared of X. Okay, and let me try this. I'm going to try to move this down. Okay. There. I mean, that helps some. Okay. So the derivative then of the, I forgot what the function was, cosine of the tangent of X is equal to, okay, F prime of U. Well, here's F prime composed with U. And that's equal to minus the sine of U. Okay, so that's that part. And then U prime is a secant squared of X. And then I want to go back to all X's. Well, what's U? U was equal to the tangent of X. Okay, times the secant squared of X. Okay. And again, this is a composition, but if I look at this and this, the whole yellow thing and this whole yellow thing, then that's a product. You have a product of the sine of the tangent with the secant squared, but inside the first part, okay, that's the sine of the tangent, that's a composition. Okay, so that's how you do the first one. And then let's do the second one. In the second function, we have the product of two functions, the product of the cosine of X with the tangent of X. So the product rule says, okay, if you want F times G prime, that's derivative of the first times the second plus the first times the derivative of the second. So that says that Y prime would be F prime, which is derivative of cosine, that's minus the sine of X, times the tangent of X, plus F is the cosine function, times the derivative of the tangent function. And there you have it. Okay, so there's a derivative of the product of the two functions, and there's a derivative of the composition of the two functions. Let's see if that, yeah, you can see them both there. Any questions? Okay, I'll take that as a no. Let's do some more. Just practicing using these rules today. What about this? The whole, okay, I want to find y prime in all of these. Okay, so y is equal to the tangent of the square root of 1 minus x. Okay, so what do we have here? Well, this is a composition 2 because I have the square root of 1 minus x, and then I take the tangent of that. And anytime I have the composition of two functions, we need the chain rule. To find y prime. Okay, so let's write the chain rule down. I always find it helps to have things right in front of me. And whenever we're using the chain rule, we need an inside function and an outside function. The inside u is the square root of 1 minus x. And the outside is the tangent, I'll call it f tangent function. So we have our inside and outside identified. And f of g prime then is, well, okay, let's go ahead before we do that. Let's go ahead and get u prime and f prime. U prime, turn it back that way. That doesn't help any. Maybe a little. Okay. Well, how about I give myself more room? Okay, so u prime, well, this is equal to 1 minus x to the 1/2. Okay, that's square root of 1 minus x. So, well, that's a composition itself. Okay, yeah. So let's talk about that. Before we talk about, yeah, so let's, well, I need both u prime and f prime here, but u prime is itself a composition of two functions. U is equal to 1 minus x to the 1/2, and maybe I should write u of x. And I've got 1 minus x on the inside, and then all of that is raised to the 1/2 power. So my inside well, I don't want to use U again. I'll call it W. 1 minus X, and then the outside is, already used F, so let's call it G, is equal to W to the 1/2. Okay, so W prime then, the derivative of 1 minus X, derivative of 1 is 0, the derivative of minus X is minus 1, so it's just minus 1. And the derivative of G is 1/2 W to the minus 1/2 using the power rule. Okay, so U prime then is G prime of W times W prime, which is 1/2 W to the minus 1/2 times minus 1. And I can write that as minus 1 over 2 times the square root of W. Okay. Oh, let's go back to, go back to X's. Minus 1 over 2 times the square root of 1 minus X. Okay, so that's U prime of X. Excuse me, a little congestion this morning. All right, so putting this all together, now we go back to the bigger function. Let's write it down here. U we said our inside function was, we'll call it U, the square root of 1 minus X, and we just found that U prime is minus 1 over 2 times the square root of 1 minus X. And our outside was F of U equal to the tangent of U. So F prime of U is the secant squared of U. And that means then that Y prime is the secant squared of U times U prime. And we want to go back to X, original variable. So that's the secant squared. Okay, well, U is equal to the square root of 1 minus X. And then all that gets multiplied by. Okay, and I guess I could write that in a somewhat simpler form. Minus the secant squared of the square root of 1 minus X over 2 times the square root of 1 minus X. Okay, so that's actually composition of 3 functions in there. On the inside is 1 minus X, then there's the square root of that, and then you take the tangent of that. But you just pull it apart piece by piece, and you can figure it out. Any questions? Y'all still there?
Yes, ma'am.
Okay, thank you. Okay. All right, I'm just going to practice on these differentiation rules today. Okay. That's all your homework is. Differentiation rules practice. How about this? Want to differentiate that function. Now you can do that in two ways. You can think of it as a quotient, which is how I've got it written, or you can think of it as sine of x plus the cosine of x all raised to the minus 1. Okay. Using the rule, let's see, that a to the minus r is equal to 1 over a to the r. and r here would be 1. Oh, by the way, I posted a list of the algebra rules on the on Blackboard. So if you want a kind of handy list of all these algebra rules, it's there for you. And anything you do algebraically is more or less contained in that list. If you see something that's not in the list, it's probably because it's not true. Okay, check that. And if you've got questions sometimes about whether a step you did is correct or not, an algebra step, put in some actual numbers and check. And don't always put in zeros and ones. Sometimes if, for example, if you're, this is totally off the subject. If you're looking at 1 over a plus b and you think, well, I'll just write that as 1 over a plus 1 over b. Well, that's totally illegal. And it's easy to see if you put in, say, a equal to 3 and b equal to 2. That would say that 1 over 5 is 1/3 plus 1/2. Well, 1/3 plus 1/2 is 5/6. 1/5 is not equal to 5/6. That rule is, that's not a rule. Okay, that's all wrong. Now, if you have something like a plus b over c, so just one thing in the denominator, that you can break up. That is a rule. Okay, so that list of the algebra laws posted on Blackboard, and which I'll abbreviate as BB. And I posted it just like last week, I think. So it should be towards the end of the list. The list of items now is very long, but it is chronological. Okay, so back to our problem. We were going to take the derivative of this function. Would you rather view it as a quotient or as a function to a power? Make a choice.
Function to a power.
All right. Function to a power. Okay. So here we're thinking about y is 1 over the sine of x plus the cosine of x. Yeah, and I cannot break that into two fractions because this is not a rule. So, oh, no, we're not. We said we're going to do a function to a power. So we're going to think of it as being sine of x plus the cosine of x to the minus 1. Okay, so now we've got a composition, really. It's a function raised to a power. So the inside is sine of x plus cosine of x, and we'll call that u. And the outside, we'll call that f.
is u to the minus 1. Okay. After you get used to these rules, you can do a lot of this in your head, but until you do, I would suggest really carefully pulling it apart, doing it one step at a time, and that'll help you keep things straight and get to where you're comfortable with these rules. Okay, so y prime is, oops, I didn't mean to change the color. Y prime is f prime of u times u prime, or same thing, f prime composed with u times u prime. Okay. So I do need u prime. And it's not so hard this time because I've got the sum of two functions. U prime is the cosine of x. The derivative of the cosine of x is minus the sine of x. And f prime is minus, okay, it's a power rule, so minus 1 times u to the minus 2. Remember, that's the derivative of x to the n with respect to x, excuse me, not with respect to n, is n x to the n minus 1. Okay, just using that rule. N here is minus 1. Okay, so we have all our pieces. F prime of u is minus u to the minus 2, and that gets multiplied by u prime. And that's equal to, okay. That's equal to, I want to go back to my x's. U was the sine of x plus the cosine of x to the minus 2 multiplied by the cosine of x minus the sine of x. And okay, you could leave it like that, or you could write it as over sine of x plus cosine of x squared. And you could also take that minus through and just write it as sine of x minus cosine of x. Okay, so I wrote it same thing in 3 different ways. For this week, I don't want you to concentrate on simplifying your answer. If you want to, go ahead. But for this week, I want you to focus on learning how to use the differentiation laws correctly. So this is as good an answer as any, okay? If you want to use a derivative to do something, and well, we're going to use them to do something because otherwise why would we bother to learn how to find them? You do need to write it in the simplest way possible, but what that simplest way is depends on what you want to use it for. So right now, this is fine. Any questions about that problem? Okay, let me pull out another one here. I have a whole list of review problems out of an old text. How about this one? And this one doesn't involve trig functions. Y is equal to 1 minus x to the minus 1, all raised to the minus 1. Well, I picked another chain rule. Okay, because I'll try to pick something else next time. Okay, so this one has an inside and an outside. Inside, u equal to 1 minus x to the minus 1. Outside, we'll call it f of u, is equal to u to the minus 1. Okay, so on the inside, 1 minus x to the minus 1. On the outside, you're taking all that stuff on the inside and raising that to the minus 1. Okay, so u prime then is, well, derivative of 1 is 0, and then you have minus x to the minus 1. Well, minus is just a constant. It's really minus 1 times x to the minus 1. And then x to the minus 1, that would be derivative minus x to the minus 2. We just basically did that in the previous problem. So that winds up being plus x to the minus 2. Okay, this minus right here comes from that minus, and this minus comes from that minus. Okay. And then the outside function, okay. Well, same thing. F prime is that function. So y prime is f prime of u times u prime, which is, here's f prime of u right there, minus u to the minus 2 times u prime, which we've already computed. And that's equal to minus, okay, what was u? 1 minus x to the minus 1. Okay, and we can just leave it like that. Some of these are not going to simplify very well. I think this one probably wouldn't. We could write it in a different form. We could write it as that, and in fact, I could take that top thing to the bottom too. So minus 1 over 1 minus x to the minus 1 squared times x squared, and then I could write that thing as 1 over x. But I'm not sure any one of those is preferable to any of the others. It's just writing it in different ways. Okay, that's your derivative. That's your derivative, that's your derivative, and that's your derivative. We just changed them algebraically or wrote them differently. They're all the same thing. Okay, how about okay, there's a lot of chain rule problems in here. Here's one. Let's see. Okay, now that's a product of two functions. We've got secant, and what's inside the secant is x, okay? 1 plus x squared plus x to the fourth is not inside the secant. It's multiplied by the secant of x. So I need the product rule. Okay, so, and we have f times g prime, f prime times g plus f times g prime. And so, well, call the f is a secant function, g is that polynomial, and y prime then is, let's just write it out, the derivative of the secant times the polynomial plus the secant of x times the derivative of the polynomial. And the derivative of the polynomial is secant x times tangent x. Then secant x unchanged and times the derivative of the polynomial. Well, the derivative, well, I've got the sum of functions over here. This 1 plus x plus 1 plus x squared plus x to the fourth. It's the sum of the constant function 1, the function x squared, function x to the fourth. The derivative of a sum of functions is the sum of the derivatives. So derivative of 1 is 0. The derivative of x squared is 2x. The derivative of x to the fourth is 4x cubed. And okay, you can just leave it like that. That one's not going to simplify very well. Factor out its secant, I guess, but that's about it. Any questions before I go further? Okay, well, let's do maybe another pair. Well, how about this? Y is equal to the sine of the cosine of x. And how about make another function? I switch functions. Both of these are compositions of functions, okay? They're compositions of the sine function and the cosine function, but the inside and the outside changed. They got reversed, and it makes a big difference. Okay, so y prime let's look at that first. The inside function is the cosine of x. The outside, f of u is the sine of u. So u prime is minus the sine of x. We learned that yesterday. F prime is the cosine. F prime of u is the cosine of u. So y prime is f prime of u multiplied by u prime is the cosine of u times minus the sine of x which is equal to the cosine of, okay, what was u? The cosine of the cosine multiplied by minus the sine of x. I'll just put the some minus out front. Okay, so that's the derivative of that function. If I switch the inside and outside, which is what happened here with this z, then whoops. Okay. Now my inside is the sine function, and my outside is the cosine. So u prime is the cosine of x, and f prime is minus the sine of u, and that means that z prime is f prime of u multiplied by u prime, so that is minus the sine of u multiplied by the cosine of x, and putting back in sine of x for u, I get minus the sine of x times the cosine of x. Any questions? Okay, well, I think that's enough examples. Go ahead and start working on those problems. The best thing you can do, yeah, the way you learn math is by doing math. You can watch me work problems all day, but you're not going to really understand this stuff until you start doing it yourself and figuring out where your snags are and so forth. But okay, let's think about something else here. Okay, so we're going to take it a step further, and we're going to start talking about something called implicit differentiation. And let me give you an example here. X squared plus y squared is equal to 1. And when I say that, I mean, I want all the points x, y, such that this statement is true. Does anybody know what the graph of this set is? No clues. Nobody recognizes that equation.
A circle, excuse me?
Yeah. Who said that?
Yeah. Me, Jefferson.
Okay, very good. That's a circle. That's, well, in fact, you call it the unit circle and plane. Okay.
Yeah.
So yeah, this set the set of all points that's supposed to be a circle. Okay. The set of all points in the plane that satisfy this equation is called the unit circle, because it's a circle with its center at the origin, and all the points on the circle are at a distance of 1 from the origin. Okay, well, that's not a function, right? Well, it's a circle, but it's not a function because it doesn't satisfy the vertical line test. A lot of vertical lines cross the graph twice. So that's not a function. Now you can write it as 2 different functions. I could solve for y, or I could solve for x too. So y squared is 1 minus x squared. So y is plus or minus the square root of 1 minus x squared. And well, there you see 2 functions. The top half of the curve, that is a function. The square root of 1 minus x squared. And then the bottom half is another function. Okay, I'll color it green. That's y equal to minus the square root of 1 minus x squared. Can I do better with green? Okay. Let's see. Well, that doesn't really look like green, but whatever. Okay, so you can think of it as 2 different functions, one on the top, one on the bottom. But you don't have to figure that out before you can find y prime. You find it in terms of x, and let me show you what we're going to do. Okay. So we've got this equation. It's messed up. Okay, we've got this equation, and this is what you called, well, it gives me 2, it actually gives me 2 functions, namely these 2. But you say that those functions are implicitly defined by that equation. Okay, so the thing is, here I've got y written as a function of x as this function, or y written as that function of x. I don't have y written as a function of x when I write this, and I don't have to have it. What I'm going to do is to think of y as being a function of x, and actually for this particular problem I found out what those functions were. You could also think of x as a function of y just as well. Okay, but let's settle on this and then find y prime in terms of y and x. And actually that will give me all the derivatives of all the possible functions that this equation or any such equation will give me. So how do I do that? Okay, so it's important that we have settled on this setup. Y is a function of X. Okay. So I take my equation. Let's see, how am I doing on time? 5 minutes. Okay. I will start here tomorrow. So don't worry if you're a little puzzled. Okay. I'm going to differentiate the left-hand side and differentiate the right-hand side. The derivative of 1 is 0. Okay, that was easy. What's the derivative of x squared plus y squared? Well, the derivative of x squared is 2x. Y squared is actually a function squared. That means chain rule. So the derivative of a function squared, whoops, how about I put that there? Okay. The derivative of a function squared, well, the inside is f of x. Maybe do. Okay. The inside is f of x. The outside is the squaring function. And that's, so I'm going to use the chain rule. Okay. 2 times the inside to the first power times the derivative of the inside. Oh dear. Okay, that's a 1. So, and let me just erase it because it gets a little confusing with the primes and the 1s there. It's 2 times f of x raised to the first power times the derivative of f of x. And that's 2y prime, okay? Because y is a function of x.
I have a question.
Okay.
So, in a problem, would we be given x and not y? Is that why we're doing it as a function?
You could think of x as a function of y just as well, okay? And if you're thinking, well, I'll just kind of stop here. We'll pick up here tomorrow. If you're thinking of x as a function of y, in fact, we could solve for those. X squared is 1 minus y, oops, that's a y, y squared. So x is plus or minus the square root of 1 minus y squared. And if you're thinking that way, then you're thinking about a function of y, okay, the left half and the right half of the circle, basically.
Oh, I see.
Okay, so you have to decide which one you're going to call your independent variable before you start, and then go from there. But it's a perfectly valid way to think, and this is probably a good stopping place. Okay, we'll start over with this tomorrow. And this is our next topic. Okay, any questions quickly? In fact, if you don't have any questions, you may leave.